let me go ahead and start talking through these. Okay, first step in any of them is to factor completely. So when you look to factor these, this top factor is a trinomial with a leading coefficient of something other than 1. So your options are trial and error, reverse FOIL, or rewrite the middle term. This is the case where trial and error is probably the most efficient way to do this. Both your leading coefficient and your constant are prime numbers, so there's only 2 possibilities for each one. So if we look at those possible factors, the 2 factors whose product would give us 5x squared for our first terms, 5x and x, there's no other possibilities. And then the 2 factors that would give us this last, or the factors of this, the last terms here that would give us a product of 3 has to either be 1 and 3 or -1 and -3. Well, the fact that the total sum of the outer and inner terms is a negative, that's telling us that our sign is negative, and so we only need to test 2 possibilities, -3, -1, or -1 and -3. Those are the only 2, which means we only have to test 1, because if the first one doesn't work, then that means the second one's the answer. So when you look at this, if we test our outer plus inner products, 5x times a -1 is -5x, -3 times x is -3x, -5x plus a -3x gives us our form. So that is the actual factors themselves. If you solve it by rewriting the middle term, again, it's not a complete waste of time. It'll lead you to the correct answer as well. In the denominator, we have this difference of squares special pattern. We have the base 5x being squared minus the base 3 being squared. So that's going to factor into the sum and difference of those bases. So 5x and 3, it's the sum and the difference. Okay, so once you factor it, your last step is to cancel your factors, simplify what you have. X minus 1 over 5x plus 3. When you write your answers in the fields, please don't put factors in parentheses unless there's factors being multiplied by them. Okay, so you'd leave it just like this. And then when we look for our restricted value, look at the factors that got canceled. What value can x not be in this canceled factor? Positive 3/5. So there's our restricted value. Is that restricted in the form itself? The simplified form? No. So that's all you're going to include as your additional restricted values. Is everybody able to understand the difference between those? The ones that are apparent and the ones that are not? If you're not, make sure you ask me. I want to make sure everybody's clear on that, but it is sometimes a confusing topic for some people. Okay. All right, in the second example, Maddie, question? How to take this factor and see what it doesn't equal? Yeah. Okay, so if we look at the factor that's being canceled and you set that equal to 0 and then solve for x, that's how you'll get these restricted values. So we add 3 to both sides and then divide by 5. And so that gives us the value that would make this factor equal to 0, and that becomes the restricted value. So the shortcut becomes the following. If you have, let's say, a factor of ax plus b equal to 0, or if that's your factor, then your solution is going to be the opposite of b divided by a. So here you just take the opposite of -3, divide by 5, and that's the shortcut form. Matthias? Now, it is true, x cannot be -3/5. That is a true statement. But can you tell that that's a restriction in this simplified form? Yeah, it's right here. The fact that this factor is in the denominator tells you that x cannot be a -3/5. So you don't need to include that anymore because you can see it. What you can't see is that there was a factor canceled that can no longer equal 0. Okay, let me give you a couple other examples really quickly. Okay, if I gave you something like this, nice and easy, what does this simplify to? 3x squared over x reduces to 3x. Okay, now, traditionally, you guys have answered this as 3x, and that's it. You're done. However, if you refer back to the original form, what can x not be? Okay, and do you know that in this simplified form? No. Since you don't know it, you would need to include x not equal to 0. Okay, now, if it was the other way around, so let's say 3x over x squared, right, and you simplified, it would simplify into 3 over x. Now, we still canceled a factor, and that factor was from the denominator. So when we look at the original form, we know that x can't be 0. Is that shown in this form, this simplified form? Yeah, you already see it. You can observe it from the form, so you don't need to include that restriction. Now, is it true that x can't be 0? Yeah, but it's apparent from the simplified form, so you don't need to do anything for that. All right, let's take a look at this second example. Again, we have a special factor form. It's the difference of two squares, a squared minus b squared. So if we can identify that a is this binomial x plus h and b is the monomial x, we can factor that numerator into the sum and difference of those bases. So if we take x plus h and x, take their sum and their difference, those are the factors of our numerator. Our denominator just is rewritten, so it's the h. So now as we simplify this, x plus x is 2x. I'm going to write it in standard form. Here, x minus x cancels, leaving just an h. Since it's a monomial factor, I'm going to write it in front, and then my h in the denominator. Okay, once I have this completely factored, I can now cancel common factors, so those cancel, leaving me with just the 2x plus h. Now, I had a factor that was canceled from the denominator, so I do have to identify the restricted values for that. So what can h not equal? H can't be 0. Okay, now, this might seem inconsistent with one of the directions I've given you guys, and that is when you write your answers in standard form, it needs to be alphabetical order. Okay, let me talk about the exception to that. Okay, the alphabetical order rule will apply anytime the letters are all from the beginning of the alphabet or all from the end of the alphabet. Okay, anytime you have a mix, so here x is from the end, h is from the middle. Whenever there's a mix on there, the early letters, so the middle and the early letters, are usually representing constants. So even though they're variables, they represent something that's usually not going to change within a problem. Whereas the x's, y's, and z's, the letters from the end of the alphabet, are usually the ones that will vary in many different cases. Okay, so if you have a mix of those, the later letters will be written first. The x, y's, and z's will always be written before a's, b's, and c's. Okay, if they're mixed like that. Okay, now if all the letters are early letters, so if it's like 2a plus b, you'll put them in alphabetical order. If they're all from the end of the order, you put them in alphabetical order. Okay, but if there are mixes, you'll put the x's or the later letters first. Again, it's somewhat inconsistent, but does that make sense? As I had said, on homework, it might not give you the right answer, but if you mix up terms on a quiz or a test, even if it's not something that I had originally accepted, I will always go back and change it and give you credit for that. So you're not going to miss points for reordering the terms, but I'd like you to get into this habit. All right. This last problem here is the difference of cubes on top, which does have, again, a special factor form. So if we look at what's being cubed, the base x and the base negative a, we're going to have two factors for that numerator. The first factor is a binomial. It's just going to be the sum of those bases. So x plus a negative a. Just rewrite the terms exactly as they are, negative sign included. And then the second factor is a trinomial. The trinomial's first term will be x squared, the first base squared. Its last term is going to be the second base squared. So negative a squared simplifies to plus a squared. And then the middle term is just going to be the opposite of the product of these bases. So x times a negative a is negative ax, change the sign, becomes positive ax, and those will be your factors. And now when we look at the denominator, again, it's the mix of a and x, so I do want x to be written first. So we're going to reorder this. When we reorder it, I also, again, want your factors to be positives. So you'll reorder it with a negative out front. So this a becomes a negative a, written second. This negative x becomes a positive x, written first. And by being consistent with that, you'll be able to see the canceling of factors that occurs. And so you have this x squared plus ax plus a all over negative 1. Okay, never write anything over negative 1, and in fact, I've already mentioned today, put your negatives up on the top. Okay, so here is one potential correct answer. Okay, now let me bring up one of the other questions that was missed by a lot of you on your quiz, okay, or you got half credit for it. Okay. In this particular problem, when you're looking to reduce a fraction, you can leave your answer as factors, always. So you can leave your answer like this. And in fact, I'd prefer you to leave it as factors. Okay. However, you could also distribute through here this negative. So you could have also written negative x squared minus ax minus a squared. Either of these would be acceptable, okay, for this type of problem. Now, where this differs is on one of the questions on your quiz, it asks you to expand. Okay, the direction or instruction to expand means you cannot write any factors. You have to expand it all out. So this form right here would not be correct if I asked you to expand. Okay, and so again, there was one where it was negative some binomial squared, and it asked, or something like that. And a lot of you put the negative out front and then squared the binomial, expanded that out. You have to distribute the negative. This would be the form if it asks you to expand. Okay, so expand actually means do not write it as factors. This right here is a factored form. It's negative 1 times this whole trinomial quantity. So it's set up as factors.